Hello, welcome back to Daily LeetCode Live, where I do the daily question raw and uncut. So we have a medium today. It is called Zero Array Transformation 2. So again, it is some second part of some question. Let's see what we have. So we have a list of numbers and a list of queries, which I think is just the bounds here. So let's see what it wants. Yeah, so that's what we are given. Yeah, we should look at the bounds as well. So 10 to the power of 5, 100k. We also have 100k queries. So we need something on or n log n. The value of I? What is this value here? We should find that out as well. Yeah, okay, so the actual numbers are also like 0 to 500k. Oh, the length of query, like for each query, is actually 3. Right, so this is probably the third argument in the query. But let's just have a look. So each query represent some stuff. So decrement the value at each index in range. So this range in nums at most by at most the value. Right. So actually we do have like a very like non-restricted kind of question here. So the amount by which each value is, so it could be chosen independently. A zero array is an array with all its elements equal to 0. Well, if this is what we want, then maybe it is not as restrictive as we thought. But let's just read it first a bit more. So return the minimum possible non-negative value of k. So after processing the first k queries in the sequence, nums becomes a zero array. And
I found some web results. I can show them.
yeah, so if no such k exists, well, we want to return -1. So I think like the trick here is to find a way, like because the query range could be very large. Wait, so yeah, what is the range here? Yeah, query. Yeah. So the range can be very large, so you can't afford to update each of them individually. So you need some other ways, I guess. But let's just see. Let's just see first. Yeah. So for this question, we have like 202. Um, so we can update 0 to. So we can update from 0 to 2. So of course we want. So one thing we can observe is it is always better to decrement as much as possible, because in the future, like if you have a smaller number, you can just decrement a bit less. Yeah, and then we have 4321, and we have some queries here, but this is not possible because we can never get the 4 to become a 0. Huh. Right. Yeah, this question, I don't see the solution straight away. Yeah, but let's think a bit. So yeah, it's definitely not good enough to get the sum. So we want a way to check if the whole range. Well, so we want a way to check like whether the whole thing becomes 0, right? Um, hmm. Hmm. I guess we can do a bit of drawing first. Yeah, so yeah, because the bounds are so large, we can't really brute force it. But are there any like easy way of like doing that? I guess like you can mark some ranges. Wait, so what if we have an what if we have another array? We start off as 0, 0, 0, and we want to see how many operations we have to do until this array is strictly greater than our original array. What if we do something like that? Would that help at all? Let's think about it. Yeah, but then like if I do this, I still have to update each of the numbers individually, which is still not great. Yeah, so we might want to like have to like do some ranges of stuff. So like let's say this range, like we have 1 here. In this range we also have a 1 here. Would that even work though? The other thing we can do is like a range tree. So if you have range updates, like you can just solve this question, but I'm pretty sure you never really have to use range trees for these kind of questions. Let's see what other ideas can we think of. Yeah, so but if we have like 1 and 1 here, yeah, the other thing that could be possible is that maybe if a number has been, well, if we have seen a number before and we know that it is already big enough, we don't have to check that number again. But well, the problem is still that the number could be very large, and if we update them one by one, and like for all the queries the value is 1, then we will have to update all of them 500k times, which is definitely too slow. Yeah. What is the acceptance rate? It's pretty low as well. Yeah, we have a tough question today. Yeah, so if we update it by range, yeah, but still we can't afford to check the whole array every time. Well, in fact, we can't afford to check every number every time as well. So what if we check one number first? Yeah, so yeah, we definitely need something that has to do with ranges, but then how do we turn like something like 202 into some ranges? That's the issue, right? And it is also possible that like we have a query that does some range over here and does some range over here, so we can't generalize this whole thing to be 2. Or like if we have a larger number, we can't really generalize as well. Right, another idea is like maybe we can binary search on the queries and see, well, because if k queries passes everything, then k plus one query will also be able to turn everything into a zero array by just ignoring the k plus one query. So it is monotonic, but would that even help? So yeah, so we still need a way to check whether that works, which is a pain. What if? Oh, but what if we sort the queries? So we have some intervals instead. So that means for each update, well, yeah, let's see. I might be getting somewhere here. So let's say we are only looking at the let's say for example 2, right? If we are only looking at that's also not a good example. Whatever. We look at the first example. So we have like 0 to 0 to 1. What if we sort it by interval? So we have 0 to 0 to, and then we have like 1 1. So if we sort it by the starts, we should be able to. Oh, 1 1 should be like this actually. Yeah, 1 and 1. So we can just get a range like from here to here. So 0. So for the 0 number, we can use log n to find that range. And because we are moving downwards only, like for all the numbers, we can have a store for the sum here. So yeah, so that will so we need a left and right pointer for the numbers here. So wait, let me actually write the numbers on the side. So yeah, so I mean the values. So those would be the values, right? So we can have a left and right pointer pointing at these things. Oh, I guess we don't even need binary search, because we can just do like a one traversal thing. Wait, we can just do that. So when we are at 0, when we are looking at the 0 index, so like on nums, so like that will be the number 2. Let me like write it here. Yeah, so 202. When we are looking at this, because we have stored all the ranges here with the starts, we can actually just we know that if we traverse downwards, at some point the left bound is going to be not big enough. Right? Yeah, the left bound is not going to be big enough. So we go to like so we just stop at this point. And we also have like a running sum. So for the values. So like because we have seen these two queries, we know that the sum is going to be 2, so that works. So if that works, we can continue looking at the next thing, right? So for the next thing, well, we can add the starting like 1 in. So that means we'll go here. So right now the sum is going to be 5. Yeah, but the other question is what happens if let's say this is 1, right? If this is 1, when we get to index 2, we actually do need a way to know how many like because we can't use any ones that ends in 1. So we do want to decrement that. So we need another array to store after we reach some end, how much we have to decrement. So in this case, once we get out of 1, so if we see a 1 here, we can yeah, so we can just add the value here. So 1, and then when we see this, we can add 4 here. Yeah, so when we get out of 1 and we go to 2, what we can do is we can what we can do yeah, so for the sum, because we know that we have 4, a value worth of 4 that ended at 1, we want to minus sum by 4. So when we get here, well actually for this case, we'll put 1 here. So the sum is 1, so we know that this actually doesn't work unless we have some 2 stuff here, unless we have more stuff down here. Yeah, but why is the value only 5? That I think my solution works, but then I don't see why the value is so small here. Is the intended solution some DP or something? Yeah, I'm not quite sure. Well, my solution would work for any value, but then they have the value from 1 to 5 specifically, and that is a bit weird. But I guess we can just I'll just go with my solution then. Yeah, the other question is it fast enough? So so my solution, the binary search would be log n, and then for each search we have to sort at most n items, so that'll be the queries. We have to sort that, and then we have another n operations because we are going from top down. So yeah, so the time complexity would be would just be this thing here. So yeah, it would be n log n log n, which is log n squared, which is reasonable. So it does work. I do want to see the intended solution because the value is so small here. It could be maybe it could be some DP, but I'm not sure. But let's just see. I'll code my solution out first. So we definitely need a what happened to my keyboard? There we go. Yeah, so we need a binary search and we need some function up here. So that will be so can transform to zeros, and then we have k, which is the number of operations, and it should return a boolean. And then we can just write that later. So let's write the binary search part first. So we have LR, so if the number of queries, so if we input the number of queries here and it still doesn't work, well, yeah, so that's why that's why we need the +1 here for the right bound, because like if this is the case, then like for the binary search, then that means well wait, what does that mean? Yeah, so that would just mean that we don't have a solution, so we want to return -1. So we want the answer, which we will set it as queries +1 for now. Yeah. And then so while L is smaller or equal to R, we can do, so middle would be L plus R divided by 2. So if can trans, miss an S here, form to 0, and we want to set the answer to be n, because that is the valid answer. And then so for binary search, if you find an answer, you want to look at the first half, not the second half. So that means we want to look at, well, everything smaller than answer. So we do that. Otherwise, we know that answer doesn't work, so we want to look on the second half. And then at the end, we can just set this as -1 actually, and then we can just do that. Yeah, that will also work, because like if at length query it still doesn't work, this is testing my binary search skills now. This is a bad mistake. Should be n -1, n +1. Yeah. So if L and R, so if L is length, like the length -1, R is length queries, and it doesn't work, like, because that will, like, from this it will be length -1, so we'll get up to length queries, which is like using all the queries, and then it still doesn't work. Yeah, so it will just jump, and then it will never get into this case here, so we just return answer here. Now we have to implement this part. So we have, so do you want to turn query? So I guess like we can do something like subqueries. It's going to be equal to q for q in queries. We can just do list slicing. So we want all the way from 0 to k, which is going to be, so that's going to give us the first k queries, and then we want to sort that. So after we sort that, because we're sorting it based on like the start and end points, right? And then we also need this subtraction thing. So subtraction array, we will set it as 0 for everything in range, well, the length of numbers. And now we should have so now for x in nums, Do we need the index? Yeah, we do need the index, I think. So enumerate nums. We also need a pointer. So the query pointer is gonna start at 0. So while the Q pointer is not equal to the length of subqueries, and subqueries Q pointer, so that points as the current query that we are looking at. So if we get to here, so like if it is 0, we will be looking at the first query. So if the starting point is, well, if the starting point is equal, or well, it wouldn't be less than, because like we're looking at this like from 0 all the way to something, so we would have looked at it before already. So if it is equal to Q pointer 0, so that gives us the start, right? If it is equal to I, we want to so we have the running sum as well. So we want the running sum we want to add value. So the value would be subqueries Q pointer 2. We want to add that. But then for the subtraction array, we want subqueries Q pointer. So that would be the end point, right? We need to add we need to add the value in there, because like after that point on, we are not going to we're not going to see any more, like we won't be able to use any values, right? Like that is like after that point. Yeah, so we have that. And then so after we have done, we should also increment that, of course, don't forget about that. So after we have gotten out of here, that means, like, let's say for 0, the pointer will be pointing at the second thing now, so the starting point is not equal, so we can't actually use that anymore. We want to check, so if the running sum is smaller than the value that we are looking for, well, that means we can't possibly solve that, so we just want to return false there. Otherwise, it does work, but we want to look at the next element now. But before that happens, we need to go to the subtraction array. Why do I keep doing hyphen here? So we want to subtract from whatever is in I. So like let's say when we get to the first element, it works, but then we have like, a total value of 4 that we need to remove. So this is where this comes in handy. And so for ix, yeah, so if all of these are done, and all of them, like none of them like fall into this case, well, we can return true because it works. And then we just run the binary logic. Let's see. Transform to zeros. Yeah. Huh? Def can transform to. Did I made a typo somewhere? So it can transform to zeros. I'm just gonna copy this. I don't see the error. Oh, transform. Of course. Oops. Oopsies. Just some stupid typo. I think it works. I'm just a tiny bit worried about timing out in Python. Okay, it didn't time it in Python. Yeah, this question is kind of cooked, but I do want to see the intended solution though. So yeah, that explains the question. Yeah, so I did the binary search way. Do they have the same idea here? Yeah, they have the same idea here, right? Wait, do they sort or not? Difference array. Yeah, so they do that. Or do they just look at all of them at once? So like instead of doing like the subquery sorts, maybe they just look at all of them at yeah, of course. They can just look at all of them at once. So there's also like a really well known question, which is like the traffic light or like something like that. But basically like they have a range of queries. So yeah, so if we go back to the first example, and if we are only like if we are looking at the first three, so what is this, like 021 021 and then 113, something like this, right? You can just mark like 0. So for this query, you can just mark the start, and then at the end you just do a -1. So that will be exclusive because like when you get out of it, you do a -1 there. So same thing for that one, and then like for 113, you turn that into a 3, and then you do a -3 here. So when you look at it like if you traverse it like that way, then like you know that at 0 the sum is going to be 2, and then it's going to be 5. Goes back down to 2, and then 0 at the end, but we don't really need that. Yeah, okay, so you don't really need to sort it. Yeah, so I missed that part. But yeah, so that will actually optimize it even further. Like because it doesn't have the n log n part. Well, it doesn't have the m log n part here. Another thing is line sweep. Is it way quicker? It doesn't have the binary search part. Yeah, so in our previous approach, right, and then checking if nums. So we're iterating over queries twice. Okay, to optimize further, we can change our perspective. So instead of iterating through queries, we can iterate directly through nums. Yeah, so for I get the solution now. So for each nums, you just want to keep adding queries in until that number is solved. And then you can look at the next one, right? So again, you use something like this. Like you use this. So you keep adding queries until, well, like the first maximum sum is larger than like num0, and then you look at the next one. If it works, you just continue looking at it. So you only need one sweep, and you're only adding each query once. Yeah, okay, that's a nicer solution than the binary search one. But yeah, either way, this question is yeah, it's definitely not easy to solve. But yeah, thanks for watching, and I'll see you tomorrow. Bye.